Good evening, everybody, and welcome to BodyTrack's webinar series. My name is Mike DiBiase. I'm a strength conditioning coach, personal trainer, and registered dietitian. We are going to be, again, like I always say, doing these, trying to do these once a month, and each one will be a different topic. If you guys have things that you want to discuss or have me discuss or any questions, please feel free to email them in, and we can certainly get them up on a webinar. I can answer any questions for you and help you out with any of your nutrition Q&A issues, goals, or anything that you just want to know a little bit more about. So without further ado, we will take and start this webinar now. Today we are going to be talking about supplements. This will be a part one of a part two series. Today we're going to be talking more about supplements that have to do with strength, muscle size, muscle hypertrophy, and muscle mass gains. So to start, sorry about the probably being a little bit blurry, but we're going to talk just a little bit about what is a dietary supplement and what constitutes it being declared a supplement compared to regular whole foods that we can purchase from the store or from co-ops or farmers markets to actually regulated supplements all the way to pharmaceutical drugs. So we do need to delineate what is actually a supplement and what is not. And so the Dietary Supplement Health and Education Act, the DSHEA Act of 1994, basically gave a very vague overview of what a supplement is. And this has been public law, again, since, as you can see, October 25th, 1994. The definition is a product, again, other than tobacco, intended to supplement the diet, meaning add to the diet, bears or contains one or more of the following ingredients, and that is either A, a vitamin, a mineral, herb or other botanical, amino acid, a dietary substance for use to supplement, add to the diet by increasing dietary fiber, or a concentrate, metabolite, constituent extract, or a combination of any ingredient described. So as you can see, it's very vague and ambiguous, but for the last 20 plus years, that has been the law, and which is why it is very difficult sometimes to decipher between what is a supplement and what is not. But that is the general overview. If you want to go into more detail, I encourage you to look up the DSHEA Act and get more information as to how these supplements are actually regulated. Again, sorry, I apologize for the blurriness, but in 2009, this was actually taken from Nutrition Business Journal. As you can see, sports nutrition, if you constitute all purchases, almost 1/3 of all purchases in supplement form or nutritional additive form were vitamin purchases. Meal replacements, ready-to-drink meals, packages that you can put in different beverages, those were approximately 10%. And then sports nutrition, whether that was ergogenic aids to increase performance or decrease weight, constituted about 11%. And you can see herbs and botanicals were almost 1/5 of the purchase. So nutrition does play a large part in people's lives, and sports nutrition and supplementation does play a heavy role in how people perceive their nutrition to be. And some people do feel that if they're not supplementing, their nutrition isn't up to par, and other people believe that their nutrition is fine without supplements. And again, it's all individual, but here are just some statistics from about 6 years ago, and I'm sure those numbers have changed since then. The considerations whenever you are looking at supplements, and the big three are efficacy, safety, and quality. Is it true to what it says it does? And does it produce results that it says it can? Again, whether that's weight loss, whether that's muscle mass, whether that's enhanced performance, whatever the goal of that supplement is to help produce. The safety of the supplement, and this is probably a big thing with people, not sure as to which ones are the safe ones, which ones are the tainted ones, what company is the safest. And that just really goes into research that people just have to do. They just can't take things on face value. There's a lot of, if you're interested in a supplement, I do encourage you to research it as much as possible and all of its derivatives and constituents and everybody else and all the other supplements that are like it to find which one seems to be the safest, appears to have the greatest regulation, and that kind of fits your moral and ethical standards and quality. Just recently there's been a lot of talk with certain companies, major headquarters and corporations that aren't saying the supplements aren't having exactly what they say they have in them, and the quality of them is actually lower than what is perceived to be, and that just goes back to, are they being regulated enough or too much, and are we demanding enough quality out of these supplement companies to actually engage in increasing the quality of them? And if we don't speak up, we don't see the changes. So that was just a little bit of a rundown of the things that you guys need to think about when you're purchasing supplements and what you need to look for. Safety, quality, and efficacy. Does it work? Is it safe? And is it of the highest standards of safety and regulation and the amount that it says it's supposed to have? So today we're going to talk about 3 of the big ones. 2 you definitely heard of. I'm sure 1 some of you may have heard of. And we're going to go over these 3 in depth as much as possible in the hour that we have. And we're going to talk a little bit about the background of each, how they interact with the body, what they're supposed to do, and why you potentially should include them in your diet if you feel that they're prudent for your goals and performance enhancement. I don't advocate that you have to take any of these, any one, all 3, or whatever, or however many. I'm just here to give you as much information as possible so you can make the most informed decision based on what it is you want and how you feel about these supplements. So we were going to talk about creatine, protein, and beta-alanine, and we will start with creatine. So the creatine background real quick. The whole idea behind creatine is to help increase the building of actual muscle, increasing strength and power, and anaerobic without oxygen performance. So quick, high-intense exercising. It has been for years, if not in the history of actual sports supplements and sports nutrition, one of the most popular and most actually studied supplements ever produced. And a lot of people don't realize that it is naturally produced in the body. A lot of people, from at least my discussions, they feel that it is an unnatural product that has been man-made, and it's actually a natural product. The liver and kidneys produce creatine, which is necessary for a lot of metabolic functions, and it's actually produced from 3 amino acids: glycine, arginine, and methionine. It can be stored as free creatine, so just floating in the blood, or actually bound to a phosphate backbone. And almost all of it, 95% of all creatine in the body, is actually in skeletal muscle, which shouldn't come as a surprise considering the whole idea of creatine is to increase muscle size, muscle hypertrophy, and actual performance. The heart, brain, testes, even eyes contain usually the rest of the 5%. And the largest proponent in the normal human diet that have the greatest amount of creatine are the animals, the fish, the poultry, the beef especially. A lot of the red meats contain the highest amount of creatine. So every time you're eating beef, steak, fish, you are ingesting creatine in whatever form it's in at that time. And about 2.5 pounds of raw meat, which I don't advocate you eating raw meat, but 2.5 pounds of it is approximately 5-gram serving of creatine. And if you look on any creatine label supplement, you'll almost usually see a serving is standardized at 5 grams. So if you're consuming 2.5 pounds of raw meat a day, you're getting enough creatine for muscle enhancement and building, probably. Again, 95% of the creatine in the muscles, 5% brain, eyes, kidneys, and testes, approximately. And the body's creatine pool estimated roughly 2 grams. So the pool maintained through the dietary intake, so what we are consuming, the food we're consuming, and organ synthesis. And one thing that we are pushing more for, especially for people of vegetarian or vegan diets and cultures, is if you are of the vegan and vegetarian lifestyle and you are looking at increasing performance and increasing muscle mass, there are heavy recommendations to consume creatine because, like we said earlier, creatine is found predominantly in meats and of animal products, and as vegetarians and vegans do not eat those, a strict vegetarian and a strict vegan, to consume it in supplement form will actually help increase those muscle strength gains, that muscle mass, and can actually increase lean body mass and potentially decrease fat-free mass at the same time. So there is an encouragement for vegetarians and vegans to consume creatine if their goals are those purposes of increasing strength gains and muscle mass. Creatine monohydrate is probably the most studied and most clinically effective form of creatine that we have seen. There are many different forms, ethyl esters, buffers of creatine, but the one that we talk most about and the one that's most studied is creatine monohydrate, which tends to be in most of the commercial supplement products because it does seem to have the greatest overall usage and efficacy of all the creatine forms, at least of to date. There are some that are coming out that may have same beneficial effects, but since creatine monohydrate is the most extensively studied and effective form, this is the one that we're always going to talk about. The ability to increase high-intensity exercise capacity. So if you tend to do more circuit-style training, low rest, high weight, high intensity, high volume, you are doing more high intense exercises, creatine monohydrate, and we'll just say creatine for the time being, has increased the capacity to perform that high intensity exercise. If we can increase the capacity to do more, we can get more out of it. We can see more muscle mass, see more changes. There have been hundreds of peer-reviewed research that have been done on the efficacy of creatine supplementation with the improvement in performance of exercise and exercise capacity and intensity and volume. Almost 3/4 of all the studies have shown a significant improvement, and hands down one of the highest rated supplements in sports nutrition history probably, and one of the most extensively studied, and 7 out of 10 studies have shown, out of the hundreds that have been done, significant improvements. So this is one we can chalk up to saying if you have the ability and this is something you desire, creatine can definitely, or more than likely, help improve the exercise capacity to whatever exercise you were trying to do. Increasing lean body mass, muscular strength, and for those interested in the high-intensity trainings like the sprint performances. Another talking point about creatine monohydrate is its lean body mass, but is it really all just lean body mass? A lot of people ask, well, if I take creatine, it's just water weight, right? That is technically not true. Creatine is a super hydrator, which I'll talk about in a little bit, but a lot of studies, again, the hundreds that have been shown the significant increases in the cross-sectional areas of muscle fibers, which is what helps produce the actual force of the muscle, helping you to lift heavier, lift longer, increase the muscle fiber size, the muscle hypertrophy, and increasing lean body mass. After a 12-week creatine supplementation, and they chose 6 grams per day instead of 5. Type 1, which we know is slow twitch, type 2A and type 2AB, sometimes known as type 2AX. 2A and 2AB are getting towards the fast twitch, what we call fast twitch fibers. 35% increase, 36% increase, 35% increase versus 11%, 15%, 6% in placebo. So people that were consuming creatine with the workouts versus people who were just working out saw a significant increases in all muscle fiber types, the slow twitch muscle fiber types and the fast twitch muscle fiber types. Almost 3 times as much, 3 times percentage in type 1, 6 times the percentage in type 2AB, 2.5 times percentage in type 2A. So with creatine performing the same workouts, that is a significant, actual tangible difference in increases in muscle cross-sectional areas, able to produce more force, able to lift heavier, longer, increase exercise capacity and intensity. And the increase in approximately 7 pounds of fat-free mass, water and muscle, leads to better metabolism, healthier lifestyle, increased exercise capacity. So another reason why creatine supplementation can be a benefit to really anybody looking to increase whatever type of musculature they're looking for. Like I said earlier, 70% of studies shown statistically significant improvements. It's one thing to say it's statistically significant based on statistics, and it's another thing to also say that I've seen it work. Observationally, it works, and both are correct. You know, observationally, we have seen creatine supplementation work for people, and in the peer-reviewed research and double-blind controlled studies, we have seen, 70% of these studies have had these positive changes. Approximately a 15% increase in actual work performance. Now, that may not seem a lot to a lot of people, but if you can increase 15% every day for your workouts over the course of time, that is extracted, and you can extract that data to show a large change in body composition, increased performance, increased musculature, strength, muscle size. So again, we don't want to look at these acutely. We want to look at these long term to see what the actual benefits are of creatine. Differences noted in both short and long-term studies. So short-term, anywhere between 4 to 10 weeks, and then long-term up to 6 months to even a year of people taking creatine. The short-term effects have been shown in these studies to predominantly be more physical performance, and then the physique benefits have been shown predominantly with the long-term use. So we see an acute change with creatine supplementation in the performance side. It's a new ergogenic aid. It's something the body has to get used to. It has to adapt and change, and it's a positive change, so we will see those performance changes and enhancements quickly. With those performance changes, we will see body composition changes. We will see decreased fat mass, increased lean body mass, increased metabolism with those greater performance changes in the long-term use. So creatine can be, a 2-for-1 deal, increasing acute and chronic positive changes for us. We can see increased performance benefits and increased physiological and physique benefits in the long term. In 1992, and this is an old study, but this is still a relatively gold standard study, 20 to 30 grams per day were consumed by people for 2 days, and only 2 days. And they saw in this study 20 to 50% increase in total muscle creatine content. So just with 20 to 30 grams per day, and again, that would be considered a loading phase, whereas I stated earlier, 5 grams tends to be the normal daily phase, or considered maybe a maintenance phase. But a 20 to 50% increase in total muscle creatine, well, the increase in muscle creatine reflected increase in phosphocreatine, and I'll explain that in a little bit, what phosphocreatine is. And because of that increased phosphocreatine, exercise, significantly greater increase in total creatine supplementation than the non-exercises. So when we had people who were exercising, we saw a greater total creatine with the creatine supplementation than the non-exercisers. So just another reason why if we have more creatine in our systems, we can have more ability to produce force quickly than compared to non-exercisers who may have a lower total creatine level. The phosphagen system, just a real quick explanation of, of what that is. So as we know, ATP is our source of energy in the body. It's produced in the cells, and that is what we utilize for all movements of the body. And that gets broken down into ADP and energy. So whenever ATP is broken down, it releases ADP and then energy. The phosphocreatine system is the phosphocreatine, which is stored in the body, gets added to the ADP, which is the byproduct of the ATP breakdown, which can then create more ATP and creatine. So by increasing our creatine stores through creatine supplementation or eating more red meats and fish and animal products, we can actually increase the phosphocreatine stores, add it back into the system to the ADP, and produce more energy for the cells to use to create energy. So it's a circle of breaking down energy to create energy. And if we can put more of that substrate, more of that creatine in our system, we can potentially load with more potential energy to be utilized to break down for energy. So it's kind of like filling up your car and then having a spare container of gasoline in the trunk to fill up and utilize of high-octane fuel that you can utilize for your car. If you want a nice little diagram of how creatine, what the role is in exercise, Volek and Dr. Volek produced this little infographic, and we'll just go through it in quick detail. So increasing creatine, actually consuming creatine, we see an increase in creatine and phosphocreatine in the muscles, which then leads to pre-exercise phosphocreatine availability. So we consume the creatine, it's in the muscles, exercise actually increases as well that creatine and phosphocreatine in the muscles. So now we have a lot more phosphocreatine before the exercise, a lot more phosphocreatine available to actually utilize. Because we have that, we reduce our dependence on glycolysis, which is the breakdown of glycogen and glucose, so we don't have to utilize those stores just yet. Since we are decreasing the dependence on glycolysis, our lactate is lower. For those of you may have heard lactate threshold, it's that point in the muscles where the lactate, the hydrogen ions, it's too acidic in the muscle environment to actually produce any more force. Well, when lactate gets too high, we can't produce as much force. So that's where we kind of reach our lactate threshold. If we can keep that lower, we can continue working out at a higher intensity. So because of the higher creatine levels, we're able to reduce our dependence on glycolysis, which helps reduce the lactate threshold. It keeps the pH high, so we don't go into too an acidic environment in our muscles, which delays the onset of fatigue. So because the pH remains high, we delay onset of fatigue so we can go longer. And if we can go longer and utilize more muscle, we can increase muscle performance. So it's not just direct, take creatine, increase muscle performance. All these things play into effect, and this is where we see that long-term effect of creatine intake and supplementation, why it can lead to increased muscular performance. Creatine in recovery, again, increasing the creatine and phosphocreatine in the muscles by consumption and by exercise. Like we said, increase the pre-exercise amount of creatine, which leads to the increase of flux through the creatine kinase reaction, and again, that is what is producing more of the ATP. Increase the phosphocreatine resynthesis, so we can now resynthesize more phosphocreatine, which is utilized to produce more ATP because we consume that extra creatine. Increase and have a higher amount of the phosphocreatine at the start of the next exercise bout, whether that's the next set or the next rep or the next 5-minute jog or the next exercise, whatever that is. And because we can increase those phosphocreatine stores, goes back to what we said on the previous slide, increase muscular performance. Creatine has been used predominantly from a lot of people for muscular performance and muscle gain and strength, but a lot more people are actually utilizing it for muscular endurance now. And we're starting to see a lot more rowers, soccer players, cyclists who are doing these long-term events actually consuming creatine. One study that was done was 16 male rowers, and it was a 7-day endurance training. So they broke it up into a group of 8, 2 groups of 8, 1 placebo, 1 consumed 20 grams of creatine for 5 days. And they performed 2 exercise tests on a rowing ergometer. BHR and blood lactate levels were measured for both groups. We saw an incremental exercise, 3-minute stage. So every 3 minutes, the exercise was changed and increased. We saw 50-watt difference per stage compared to the placebo group. So they were able to produce more power over time when they consumed the creatine. They also saw a max anaerobic exercise against a constant load. So a constant load of 7 watts per kilogram, they were able to go harder at a higher maximum level compared to the placebo group. And again, that was only for 5 days. So this is where we said earlier, acutely in those short times, we will see those performance enhancements. But imagine if those people were doing those workouts where they were able to maintain that higher maximal anaerobic exercise and increase during those incremental exercise 3-minute stages. That's more work over a 6-month period, a 9-month, a year period. They're able to do more work, increase more muscle mass, increase and a better positive body composition change compared to the placebo group. Like I said earlier, creatine is actually a super hydrator, a hyperhydrator. So when we consume creatine exogenously through supplementation or through food, it actually pulls in more water into the cells. So it actually super hydrates us. A lot of people used to believe that creatine would dehydrate you. It's actually the opposite. It hyperhydrates you. So you'll see some people who exercise in extreme heats and extreme environments will actually compensate by taking creatine to actually store more water in their bodies to actually be utilized for that long duration exercise in the heat where they may not have great access to exogenous water or different drinks and beverages. The one caveat of that is with creatine holding more water, there can be a water weight that is associated with that. So people may feel slightly bloated sometimes with consuming too much creatine. So more endurance athletes tend to stick to a low end of creatine consumption, around 2 to 3 grams, to keep enough water in their system and still see performance enhancements, where you'll see bodybuilders and strength and muscle mass athletes consume much more creatine to potentially have that water weight and increase muscle mass and mass gaining at the same time. Total body water, so the more gray areas were the placebo and the greener areas were the creatine. This goes back to the superhydration over the course of 4 weeks. You can see that the creatine was able to store more water than the placebo, the total body water, and that is significant compared to week 0. So we can say creatine is a superhydrator and able to keep the body to store more liters of water. Another topic about creatine some people have brought up about creatine for kids, and you'll see that some organizations, ECSM for one, does not recommend anybody under the age of 18 consume creatine because there have not been enough studies to significantly say that it is safe for them, but the studies that are coming out, we are seeing that creatine is safe considering kids do eat meat, do eat fish, do eat foods that have that amount of that do have creatine in it, and it is naturally produced. So this goes back to the efficacy and safety and quality of that creatine supplementation, which I think needs to be addressed, especially with children. But we are seeing that there have been studies that have shown creatine has been useful in leukemia, muscular dystrophy, traumatic brain injury, whether that was due to accidents, due to contusions, concussions, severe accidents and car crash or anything like that. Even athletes like swimmers who are always in the water, we're seeing that the creatine, again, muscular performance, enhanced performance. In infants with GAMT, there has been only one study done to that. We're not going to go into that one, but more and more studies are showing that the creatine is not just necessarily for increased muscle gains and sports performance. We are seeing that this can be a potential additive for people with disease and chronic issues like muscular dystrophy and leukemia and other things. And we're actually seeing that in the elderly, it is actually helping maintain that muscle mass in elderly to actually keep continuing on to living normal, active life. So the bottom line, creatine is safe and effective, according to the 70% of the studies that have been done. But I do put a caveat in saying that in lab settings, there needs to be more abductive reasoning and research and observational long-term research with creatine to show the effects in an actual setting, like on a track field or a soccer field or a basketball court, to see if it does have those actual significant effects in sports performance. We know that it can increase muscle mass. We know that it can increase muscular endurance and performance and hypertrophy, but will it make somebody, because of those positive changes, a better soccer player, a better baseball player, a better golfer? Those are things that we have to start looking at now. So safe and effective in the lab setting, productive in increasing the muscle fibers, cross-sectional areas, endurance, but to actually say, will it increase sport performance and the actual playing of that sport? Can't say that yet. Next one, we're going to talk about protein. And protein is all around us. We constantly consume it. People should probably consume more of it, more leaner, healthier versions of protein, but we're going to go over kind of how protein works in the body and what about protein needs to be consumed and known. Protein is essentially the building blocks of skeletal muscle and pretty much everything else in the body. Everything almost requires either a protein or a protein carrier or an enzyme, all derived from different protein structures. Total protein needs, and this varies to a large percentage, 50 to 175% greater in athletes than just people who sit around, the sedentary lifestyle people. So again, that is a large number, 50% more to almost 175% more protein. And so it varies depending on how active you are, what it is in that activity that you are doing, and what are your goals, of course. There's been long, extensive clinical research on different types of proteins, different structures, different lengths, different brands of proteins. such as milk protein, which is essentially broken up into two different whey and casein. Plant-based proteins, soy, wheat, and of course the egg proteins. Determining the protein quality. So there are 20 amino acids in the body, 9 essential amino acids, which we'll just call EAAs, and 11 non-essential. So the non-essential mean we have to consume them in the diet. The non-essential means our body produces them already, and we don't necessarily have to consume them through the diet. Please do not misconstrue the word non-essential as not important. That is far from the truth. Those non-essential amino acids play a very critical role in our body and how those essential amino acids are utilized and created. It just means that we don't need to consume them because our body will naturally produce them. And the essential amino acids means our body will not produce them. We have to consume them. We define protein quality as the capacity to provide the essential amino acids. So we would consider a complete protein providing all 9 essential amino acids. If a product only had 8 or 7 or less, we would call that an incomplete protein. And the way to make that a complete protein would be to add another food base that may have the other proteins missing. So, for example, beans, different legumes may have 1 or 2 amino acids missing. So we would consider that an incomplete protein. And if we combine it with corn, that corn may contain those 1 or 2 amino acids that the beans were missing. So because of those 2, we consider those 2 together supplementary proteins, and together they make a complete protein. And this is where the idea of increasing the variety of different foods, especially vegetables, also comes into play, because we can get those complete proteins through that variety of food. The essential amino acids stimulate as much protein synthesis, and protein synthesis is that increasing in the actual protein fibers and muscle fibers, as a whole protein with same essential amino acid content. So some people prefer just to take the essential amino acids. They can take that in supplement form. Other people prefer to eat chicken and steak and have those essential amino acids in there. And some studies have shown that just taking the EAAs by themselves have shown the same protein synthesis as eating a steak. Some studies have not. That is just, there's more research that needs to be done on really what is the difference between the whole food and just the amino acids other than the calories and the protein quality and amount. There are fortunately many choices for proteins. The quality, again, of the protein is going to be determined by the essential amino acid content, the 9 amino acids that are essential that we have to consume. A complete protein, like I said, is something that has all 9 amino acids in it, all 9 essential amino acids, and a few examples are the dairy, the eggs, meat, and fish, so usually something animal-based. Incomplete proteins, things that are missing 1 or more of the essential amino acids, are grains, vegetables, fruits. That's why the combination of all of these is critical. We just don't say that to increase variety and to feel that everybody's trying something new. It's because of the complete protein that can be made from 2 complementary, supplementary proteins that will complement each other in providing 1 or 2 of those missing amino acids. The supplements, whey, casein, milk, and egg proteins have been shown in studies to be the best at the bioavailability of the protein, increased chronic performance, body composition changes, and the absorption of the protein. We have seen in many studies that whey, the lesser part of the milk, is faster than casein. So in absorption speak, when we're talking about it actually being broken down and utilized and absorbed through the intestines, whey is much quicker, which is why we always promote whey after the workouts because that's when our body is primed to absorb the quickest, and we want the quickest during the most optimal times. So we would heavily consider going for a whey protein supplement. But we have seen that casein and whey do produce similar increases in protein synthesis. So if they are going to be similar, but we can get it faster, why not go with whey? And one of the keys pre and post exercise is to have those complete proteins, to have those amino acids available, those essential amino acids available for the workouts and after the workouts, so we can actually have that total amount of creatine content in the body throughout the day and every day. The milk proteins, we have seen kind of a resurgence of milk, especially like chocolate milk after workouts, because of the sugar, the increase in insulin, the increase in substrate, location and transportation to the muscle fibers, and the complete protein that is milk. We have seen that it has sped recovery, so people are able to go longer and do another bout of exercise in a shorter amount of time. Increase the glycogen replenishment, so as we work out high intensity workouts, long duration workouts, that glycogen, our stored glycogen levels decrease, and we see those replenishments happen, especially with milk proteins. And also improve the hydration status. We're seeing more research that's saying consuming products that have carbohydrates and protein in them, milk, helps keep water inside the cells better, so increasing that cellular hydration level better than other not incomplete proteins. So we see many benefits to the muscle consumption following exercise. Better recovery, so we can go again quicker. Increased glycogen replenishment, so we have the ability to utilize the glycogen for the exercise sooner, so we can go again quicker, go again a little bit harder maybe next time, and have that hydration at the cellular level improved. And we can, again, like we said earlier, break down milk into two protein levels, which is casein and whey. And whey is the quicker absorbing protein, casein is the slower, but we do see similar muscle protein synthesis with either casein and whey. We're not going to get too much into leucine, but leucine seems to be a rate-limiting branch-chain amino acid that actually increases at the highest level compared to all amino acids, the greatest increase in muscle protein synthesis. So there's been more and more research with leucine and just consuming leucine to actually see that muscle protein synthesis increase. The casein contains about 9.3% leucine, whereas whey protein contains approximately 11% leucine. So if we can get more leucine in the body, we can potentially see a greater activation of the leucine threshold, meaning we've met a certain amount of leucine necessary for protein synthesis. And if whey has more, we don't need as much to meet that leucine threshold. It's still recommended that both proteins be consumed, but if just specifically speaking on leucine, whey protein does have the most. Meat versus plant-based protein. So the difference in some proteins, of course, is whether or not it is from a meat product or a plant-based vegetable legume product. And one thing that we're seeing is vegetarian diets tend to be lower in complete proteins and the branched-chain amino acids and essential amino acids because they are not normally consuming those complete proteins compared to an omnivorous diet, someone who eats plants and animal products. With supplementation, getting plant-based, vegan-based, vegetarian-based proteins that are made according to whatever lifestyle that person is living, whether it's vegetarian or vegan or whatever derivative of vegetarian they choose to follow. Finding those supplementations and then complementing each food item with other complementary proteins, it is possible to have those complete proteins in a vegetarian diet, where we see vegetarians having that large variety of different fruits and vegetables which have those necessary proteins in them to make the complete protein. And if they're still unable to meet their protein needs, then a supplementation of a vegetarian or vegan-based protein supplement may be necessary, or may be a good choice to actually see those enhancements and those performance benefits. There has been a lot of talk about soy lately, whether or not it is a good protein. It is considered a lower quality complete protein. It can be considered complete. Some people still do consider it an incomplete. I think it's a little bit back and forth. We will consider it a lower quality complete protein. It has approximately 85% lower of the essential amino acids than just regular milk. But if we were to compare whey, casein, and soy, soy would be the last one to choose based on performance enhancements, availability, increasing the muscle protein synthesis. So whey has the fastest absorption, has the highest rate of protein synthesis. Casein is a little bit slower, has a little bit less or comparable protein synthesis, and then soy would be under that, where it has the lower amount of muscle protein synthesis. Still has muscle protein synthesis, but compared to casein, whey, milk proteins, it's less than those. So soy is still a very good choice for anybody, vegetarian, vegan, omnivorous lifestyle, but since it is on the lower end of the essential amino acids and the muscle protein synthesis tends to be less with soy, it may be prudent to complement that soy protein with another plant-based protein to actually see those complete amino acid profiles. In order to raise the protein muscle synthesis and actually see that change, there's been a lot of talk about leucine in the last few years, where to reach that level, you need to have approximately 2 to 3 grams of leucine, maybe up to even 4 grams of leucine consumed to actually see that muscle protein synthesis occur. And you can actually get 2 to 3 grams of leucine by consuming approximately 25 to 35, anywhere in between there, of whole protein sources that contain the branched chain amino acids, which are leucine, isoleucine, and valine, or a combination of the complementary proteins. It just may have to be more so to actually see that level, because again, leucine tends to be higher in animal-based products, whey, milk, casein, fish, beef, and a lot less in the plant-based products. So there may have to be an increase in the plant-based proteins, or at least an increase in complementing the plant-based proteins to see that leucine threshold met. We're not going to get too much into the leucine, but just to give you an idea of how that muscle protein synthesis, more and more research is coming out that leucine tends to be the rate-limiting factor for that. The ingestion of whey protein, this is a study done in 2014. 20 grams of whey protein 3 times a day added to just the habitual diet, a normal, unregulated diet for overweight or obese men and women. And you can see in the left column the fat mass percent change. So you have placebo, placebo plus resistance training, and then prize, which is a different type of workout with exercising, nutrition, increased protein, and you can see that the fat mass percent change decreased the greatest amount in the prize group, which has the increased whey protein and exercise, compared to the placebo and just placebo plus resistance training. So we saw the greatest reduction of fat with the exercise and whey protein group. And then we also, if you see in the right-hand column, increase in lean body mass, which is muscle. We saw, again, in the prize group, the whey protein and exercise we saw an increase, the greatest increase in muscle in that group compared to the placebo and the placebo plus resistance training. So with whey protein and exercise, not only did we see the greatest increase in muscle, but we also saw the greatest decrease in fat. So we can say, according with this study, that whey protein with exercise and the right modifications to the diet and workouts, we will see the greatest body composition changes and hopefully performance changes in someone compared to someone who's not working out and just eating, or someone who's working out and eating but not having that increased protein, that whey protein, 3 times a day. So that 20 grams may meet that leucine threshold, which is why they probably picked 20 grams for this study, 3 times a day to have that multiple leucine threshold met every day. Increase the whey protein, and they saw the greatest body composition changes. Decreased fat mass, increased lean body mass. This is the International Society of Sports Nutrition's position stand on protein. I'm not going to go over all of these. You're more than welcome to read them. But after extensive years of studies and multiple PhDs and medical doctors and registered dietitians, these are their 7 stances as to how protein is affected, the recommended amount, how they evaluate protein based on diets, and what their recommendations are for consuming, timing, and those kind of things for protein. And last is probably the most difficult one for people to wrap around, beta-alanine. It's one that many people don't hear about, or that there has been research that shows it doesn't work, it does work, and we're going to give an explanation as to what beta-alanine really is. So there's a buffering capacity that we want to look for in skeletal muscle. So this goes back to the pH, the acidity or base, the basicness of your blood and muscle tissue. And if we can, as we work out through each set, through each rep, our body becomes essentially more acidic. The muscle fibers get broken down, lactate with the hydrogen ions. As more hydrogen is increased in the body, the blood, muscle fibers, and the environment just becomes more acidic. The higher acidity that our body, that our blood, and the muscle fibers becomes, the less force we can produce, which means the workouts will suffer and they'll probably stop, and we'll have to clear that acidity and clear that lactate so then we can start again. And sometimes that takes minutes, hours, if not days sometimes for people, depending on their workouts and their duration and intensity. So if we can buffer the blood and buffer the muscular and the muscle fiber environment so it doesn't become as acidic, we can theoretically then continue to work out longer, greater duration, higher intensity, to a point where we can extend that buffer limit, that threshold, that lactate threshold. And beta-alanine is being researched to show that that has happened with increase in supplemental beta-alanine. Research has shown that it can help with that buffering capacity by increasing carnosine. So it is the rate-limiting substrate in carnosine synthesis. So what happens is, it's not the beta-alanine itself. It's beta-alanine helping to produce the carnosine synthesis. So carnosine is a dipeptide. So it's made of beta-alanine and histidine. And the majority of carnosine is found in the fast-twitch muscle fibers, the type 2A, type 2AX that we talked about. And carnosine is very effective. It's in the body. It's already inside intramuscularly. It's an effective buffer. So this is kind of the body's, the inside the muscle's first line of defense. It's already there, and it's already being produced because of beta-alanine in the body and histidine in the body. So as hydrogen builds up, it becomes more acidic, carnosine kind of kicks in. So if we can increase the carnosine levels, through beta-alanine supplementation, we can potentially increase that buffer capacity. So the body can take on more of those hydrogen ions from lactate and keep the pH of the blood and intramuscular environment at a normal pH level, so we can continue that workout at that intensity, that duration, and that volume. Suzuki in 2002 saw the significant, again, statistically significant, and a positive relationship between actual carnosine, intramuscular carnosine in human skeletal muscle and high-intensity exercise performance. So the higher levels of carnosine that they witnessed in people, the higher intensity exercise performance they were able to see. So some people then just say, well, why not just take carnosine if that's what is needed for the buffer? Well, more studies have shown that actually ingesting carnosine does not help the buffering mechanism. It's actually the beta-alanine, which tends to be the rate-limiting factor of carnosine. Increasing that helps produce more carnosine, which helps create more of a buffering agent. So the idea of increasing carnosine is there, but we have not seen that in studies. We've seen more and more of the increase in beta-alanine helping to produce carnosine has been the effective regimen. The long-term effects and long-term training with the carnosine levels, bodybuilders tend to have the highest level compared to vegetarians because of the high-intensity workouts and the ability for that body to have to buffer and adapt and change that lactate threshold so we don't see those hydrogen ions build up. Those bodybuilders tend to do very high-intense duration, volume workouts where they have those natural carnosine levels, higher concentrations, than compared to, sedentary vegetarians, elderly population, and, getting up higher to physically active sports science students, people who know the information or are actually applying it. So we actually see people who are more active doing those high-intensity workouts have to have a higher carnosine concentration to balance out those increase in hydrogen, lactate, and buffer the blood in the intramuscular environment. Carnosine, because of beta-alanine supplementation and increasing the beta-alanine capacity to produce carnosine, enhance the buffering capacity. So short-term, 30-second sprints to even 1 to 2 minute sprints. In many studies in 2007 and 2006, from Raymer, Edge, Stout, Jewell, Suzuki, have all shown that they've increased with repeated sprints. So actually being able to maintain that speed and intensity over repeated times. Time to exhaustion, increasing the time compared to a placebo where they have to stop. Beta-alanine consumption, increasing carnosine levels, increasing that buffering capacity, increasing the time to when they actually exhaust so they can go longer. Peak power output, being able to actually put out more power in the same amount of time compared to placebo. And anaerobic threshold, again, pushing that body to the limit without using oxygen and increasing that level so they can actually utilize more of the anaerobic substrates at a higher level. Naturally, like we said, found in higher concentrations in bodybuilders. So it would assume that if it's in higher concentration and they're constantly developing their bodies to be in that acidic environment, to increase beta-alanine supplementation. And this does not just go to bodybuilders. This goes to any people who are constantly working out, who want to push those limits, increase that performance. And again, when we see increased performance, we can see potentially increase in those body composition changes. Decreased fat mass, increased lean body mass, better bodies, better weight management. Again, through secondary and tertiary mechanisms. Carnosine occurs naturally in meat, so when we do consume those meats and chicken breasts and different types of poultry and animal products, we do increase carnosine. More studies need to be done on increasing those foods to actually produce more carnosine in the body compared to just beta-alanine supplementation. But for this talk, we're talking about beta-alanine supplementation increases carnosine levels to increase the intramuscular buffering capacity. If we take a look at effect size, exercise duration, so less than 60 seconds, 60 seconds to 240 seconds, and greater than 240, so approximately 4 minutes, we see across the board placebo and beta-alanine. Beta-alanine had a greater effect in less than 60 seconds compared to placebo. In 60 seconds to 4 minutes, we saw a dramatic increase in effect size and exercise duration with beta-alanine compared to placebo, and still, even after 4 minutes, beta-alanine consumption compared to placebo. So consistently we see with beta-alanine consumption, we see a greater effect size even during multiple different exercise durations compared to placebo. High-intensity interval training, so some people have taken, one study, and many studies you see are about 6.4 grams of beta-alanine and 3.2 grams of beta-alanine, depending on how much they're consuming and what they feel is necessary. They saw in that high-intensity interval training with beta-alanine consumption an increase in VO2 peaks, so that oxygen utilization at its highest level, time to exhaustion, so people were able to go longer during the workout till they felt completely exhausted. The training volume, essentially the total amount of work that they did in that workout, and an increase in lean body mass. So that beta-alanine compared to placebo, compared to the control, we saw an increase in oxygen utilization, duration, the amount, and musculature. Just another part of beta-alanine, comparing football and different cycling and wrestling, different events, strength and power, with beta-alanine supplementation, and we saw increase in lean body mass in football players, all the way up to naturally we would see probably more in the strength and power because that is what they're training for. So we see most supplementation systems are of anywhere between 3 to 6 grams of beta-alanine per day for approximately 4 weeks is when we're starting to see the actual changes occurring, and more of the research showing a split dose 2 to 3 times per day of 1 to 2 grams per dose. So if we divide that out, that comes about 3 to 6 grams per day divided over 3 doses. That has shown the best efficacy of the utilization of beta-alanine and having that buffering effect of intramuscular hydrogen ions. So in summary, for beta-alanine, I'm not going to go over all these, but you can see that it increases skeletal muscle buffering capacity by increasing the carnosine levels. So if we can increase carnosine levels through beta-alanine, we can have a better buffering capacity, go longer, increase lean body mass in a more chronic state, increase VO2, oxygen utilization at its highest peak, and increase performance at the same time. There may be an additive effect during high-intensity exercises and resistance training versus training alone on just the normal muscle carnosine level. So people would tend to have higher ones already, and then adding beta-alanine, there may be a doubling effect. We may see even a greater effect with that beta-alanine consumption. 3 to 6 grams seems to be enough for at least approximately a month, and we do see it significant increase in skeletal muscle in trained and untrained men and women at the same time. So the final summary of the 3, and this is a very quick summary of all 3. Creatine and protein and beta-alanine can all lead to increased lean body mass and possible enhanced performance, decreased fat mass through chronic usage and actual adaptation to those enhanced performances, and increased muscle protein synthesis. For creatine, approximately 5 grams a day that keeps the cell saturation level of creatine at maximum, so we can utilize that creatine for phosphocreatine and ATP production, energy production, for the cells to use in our exercise bouts. And with more and more research coming out, it appears to be safe and effective for children, adults, elderly, in performance enhancement situations, weight gain or loss, muscle mass gain or loss, and even the vegetarian and vegan lifestyles who are looking for that performance enhancement without increasing animal product consumption. Protein, approximately 20 to 30 grams per meal will help guarantee that leucine threshold is met, which is approximately 2 to 4 grams in those 20 to 30 grams per meal, and anywhere between 1.2 to 1.7 grams per kilogram per day needs to be consumed to see those positive effects. And whey has the better absorption compared to casein, which is better compared to soy. And then lastly, the beta-alanine, rate-limiting substrate for the carnosine, so we see better enhancement with increased beta-alanine consumption rather than just carnosine consumption. Enhanced buffering capacity during high-intensity trainings, whether that's interval or just high-intense workouts. And we're looking at 3 to 6 grams per day split into 2 to 3 doses. So 1 to 2 grams per dose to equal those 3 to 6 grams per day. All of these have shown significant studies and have shown significant positive effects on all these things. There are studies that show some of these have no effect, but take the research for what it is. Do your own research. Be as critical about the research as you can. If you are looking to consume these, get a better idea of the efficacy, the quality, and the safety of these products, so you have the most knowledge and the best comprehension if these supplements are right for you and right for your performance and body composition goals. And that is it for us. I hope you enjoyed this one. We'll be doing the part 2 next month on weight loss, fat mass loss, and endurance training, and we'll be talking a little bit more about some of those supplements. So any questions, please pass them off to Body Track, and I'll be happy to answer them as they come through. Have a good night, and see you next time.